So in the previous example, we looked at limits on the left and the right-hand side of a function, but we really want to be able to talk about behavior like this in the middle of the function as well. In that case, x isn't approaching negative or positive infinity, x is approaching 0 for that function in that area highlighted in blue. So we also have limits at a certain value. What is happening to a function as x approaches a number and not just infinity or negative infinity? So again, we're using the value c here to talk about what x is approaching. And as x gets closer and closer and closer to that c value from either the left or the right, the limit is what the function is approaching, some y value there. So we did this way back in chapter 1 using a table. So I do want to go through those table steps with you again to remind you how to use our calculators and the features there. And then we'll also look at a cleaner graph on Desmos as well. So let's go ahead and stick this function into our calculator. It's been a while since we've had to do this. So I'm starting with a brand new calculator screen here. Hit 1, get a new document. I don't want to save anything. So I'm going to start by adding a calculator. So there's a handful of different ways to do this on your calculator. I like to store my functions in an actual calculator screen instead of playing around with the graph menu. So to do that, you have to give your function a name. If you name it f1, then it's going to automatically graph for you, which is nice. So f1 of x, and then we want to use the define key located up here in the top right corner. Looks like a colon and then an equal sign. This will allow you to give your calculator a definition for f1 of x. In our case, it's x minus 8 over x squared plus 4. Hitting enter, you'll get that notice done. This is your calculator saying, done the job, boss, move on. You can do a lot with a function just on this screen. For example, I can evaluate it. If I want to know f1 of 2, I can type it exactly the way I'd write it by hand. Calculator will give you back f1 of 2. The other thing that I like about these Inspire calculators, if you name your functions this way, f1, f2, f3, I can hit Control plus page and add a graph, not geometry, pardon, Control plus page and add a graph. That function will automatically be stored in the f1 spot on your graph. Clicking enter will then bring that graph up so you can see that function visually. If you name your graph, if you name your function anything else, you name it Bob or George or Billy, it won't automatically show up on the graph. So I recommend using kind of those boring names. So here we have a picture of that function. Control T brings up a table, and the table as written isn't super useful since we're trying to find the limit as x approaches 2. Or right here, as x approaches 2. We don't really care about what the function value is at 2. We want to know what happens as x gets really close to 2. So to fix that, menu, table, and edit table settings will allow you to change the independent variable from auto, and auto means numbers like 0, 1, 2, 3. You can change it from auto to ask. Now your table is completely blank all of a sudden, but what this allows you to do is tell the calculator what values to look at. So 1.997, 1.998, 1.999. In other words, as x gets really, really, really close to 2, what happens to my y values? We can do the same thing on the other side, 2.003, 2.002, 2.001, and we can see that same behavior. What is happening to my y values as x gets closer and closer and closer to 2? So we can see that on the left-hand side, scrolling up on my table a bit, on the left-hand side, we're getting really, really close to the value negative 0.75, because notice it's 7515, then 7510, then 7505. So we're getting closer and closer and closer to that. On the right-hand side, same thing. We get 0.748, 0.749, 0.7495. So getting closer and closer and closer to a particular value. So in Chapter 1, we actually filled out this table with those values. Evaluating that limit, though, doesn't actually require us to build the whole table. We just can use the table to help us see that, oh, this function is approaching negative 0.75 or negative 3/4. Again, it's doing that both on the left and on the right-hand side as x is approaching 2. Both the y values are approaching that negative 3/4. So as far as what do we have to do, this is what we're looking for, the actual value that the function is approaching. I'll look at a couple more examples using the calculator table, and then we'll start looking at some graphs, because it's usually easier to play with graphs than tables. So in the interest of time, I've already gone ahead and programmed 9, 10, and 11 into the calculator. You'll see I've called them F1, F2, and F3, so I can look at them one at a time on the graph. So function 1 is just a straight line, mx plus b, it's linear. Control T brings up my table, and again, menu, table, edit will allow me to set that independent variable to ask. So in number 9, we want to find out what happens as x gets close to the value 4. So some values that are close to 4 would be 3.997, let's try that again, 3.998, 3.999, and here on this left-hand side we see 9.991, 994, 997. We're getting really, really close to the value 10. To see that that's also happening on the other side, on the right-hand side, we can do 4.003, 4.002, 4.001, and we see that y is getting closer and closer and closer to the value 10. Let's go ahead and do the same thing for the next function. Our second function is a parabola, a little bit more interesting. Control T brings up the table, and note that it is showing me both F1 and F2, so we do want to be careful there. A nice shortcut is you could do menu, while the table is selected, you can do menu, table, choose, and that way the function that you want is the first one in the table, so you don't have to keep scrolling back and forth. Additionally, we want to make sure that we have that table set to ask. So for this example, for number 10, we want the limit as x approaches -1. So we have to look at numbers really close to -1. So numbers like -1.003, -1.002, -1.001. And note that we are getting really, really, really close to -3. Our numbers are getting closer and closer and closer. Likewise, we want to go on the other side of -1. So looking at numbers like -0.997, 998, and 999. Once again, we can see that we're getting really, really close to the value -3 on that side as well. So this limit will be -3. And last out of this first row, we have a cubic function, and we want to find out what happens to this cubic function as x gets close to -5. So I can take a look at x at -5.003, 002, and 001. That will let me know what's going on there. It looks like we are getting closer and closer and closer to the value -1. Hey, if you're ever not sure, you can always enter another one in there, 0.0001. Now we're getting really close. Again, as we get closer to that x value of -5, we can see y is getting closer to -1. We can go on the other side of -5 as well, taking a look at values like 4.998, and then -4.999. And of course, if you were ever unsure, you get even closer, -4.99999. Very nice. So as we get closer and closer and closer to the x value -5, we're getting close to the y value -1. So of course, the calculator table tool is not the most user-friendly. It is the one that's available to you on quizzes, tests, and finals, so it's one you want to be comfortable using. But in order to really look at a bunch of examples quickly, we're going to go ahead and take a look at a shortcut on tensed modes. See you soon.